this is lecture 29. Let us continue to program the search engine based on the multicasting framework. So last time we stopped here. Okay, we just finish the search child pair, right? This is no much difference from what we have programmed for the peer-to-peer framework. It's very similar to not similar. The code structure, the design pattern are exactly the same. The difference from that, we need to use this. This is the upper level application computing resources. That's a little bit difference. Okay, next, what we need to program is dispatcher. So dispatcher, because here the child need to receive some messages forwarded by its parent, forwarded by its maybe root. So we need to follow this code to design our system. Okay, open this one. Let us take a look. Okay, the first one is same thing, right? For this code, we also need to design this code because the root method, the root IP address should be received from the root. When the system started, the root will make a broadcast. So all the children will receive the IP address of the root. So we need to implement such a method. However, here a little bit difference. So we need to the message we can reuse this message, but the thread a little bit different. Okay, let us implement this thread. Okay, is the child. Okay, implement this thread. And then we need to extend the parent class notification queue. The message is saying you must be familiar with the code. We program many times in such design patterns. We can copy this code here. And then remove those comments. Okay, actually this one can be reused, but we implement a new one. Doesn't matter, we implement a new one, we can use this one. This one can be reused as well. And the dispatcher, not this one, not dispatcher, child pair need to replace. Okay, if we program from maybe, by the way, program with the multicast framework is not the general approach. It's not the best approach, at least, and I will show you better approach in the next classes. But I think through this programming, you will be more familiar with grid free, and you can see it's convenience. It's convenient to program with grid free, even though the system is complete. Okay, so finish this one. and then we still need to create a creator for this thread. Okay. Then remove arrow. Okay. Then okay. That's easy, right? This is one of the simplest design patterns. Okay, now we can work on here. Okay. Right. Next. What about this one? This is we need to have a not unicast. This one we need to follow this code, this example, because there is a unicast notification from the crawler to the multicasting framework. So we need to follow this code, follow this code level design patterns to implement our system. So open this code, let us take a look. Copy this line, copy this. No, not need to copy. We just need to create a new design pattern. It's called crawl data unicast notification thread. Okay, extend. What about the message? This message should be crawl data notification recreated in previous classes. Okay. Okay, we just need to keep on working on this code. And then what else? We can make, another issue is because we need to keep this data. All the data generated, crawled from the web pages, other websites, we need to save those data into a I think I need to put it into, we need to design a database. But usually we need to design because usually the system is huge, but because we have limited time, just design a simple one that is similar to a database, but it just keep the data in memory. It's very simple, but we can name it as a database, but it's a very simple one, not an actual database. So we can name it crawldb, right? Crawldb, right? That's fine. And, we can also define it as a singleton. That is easy to be used. Singleton. dB, right? Okay, next. Here. Next, we need to save all the data into such a database, but we need to design a data structure to save it. Okay, it's a map of we can save data in this way. Okay, it's just not a real database, so we just put, because all the data is put into the memory. Okay, initialize the map, and then just say data, say the data and k value. Okay, just keep the data in the database, and then we need to check whether one piece of data we query exists or not. Okay. If it existed, the data will be returned, and that's the retrieve value. So it's easy. Actually, for your system, you need to use some your database are using some inverted indexes system to retrieve data, but here we just want to simplify the design, because our system is I just want to present the distributed architecture, distributed system programming. Okay, the DB is finished. It's a simple one. So for this case, when the data is received, we need to put it into the database. Okay, put it into database. DB. Say. Here I use one API I created. This one can generate a unique hash value, hash string, based on the data we try to receive. So that's a K, right? Okay, next is a text. Okay, then what else? Because it's a unique unique casting, so we do not need to forward any data. We just dispose after data is saved. Just dispose the message. Okay. Here is the application code. Then we need to create a creator for this notification queue. Okay, this one we just follow this example. Follow this example. This example, the data. Okay. Now the thread. Okay, the thread. Import the notification. Okay, next, we return to here to server dispatcher and then put the thread here. We need to change replace the thread. So I need to be changed. Okay. So it's the data unique custom notification. Now what else? The query. We need to process a query. Query is a broadcast request. So we need to open this one. Follow this example. Search query broadcast request thread. Okay. You can see here, one issue you need to pay much attention to. This is request thread. In the previous classes, for the thread that named as request thread, we need to extend request queue. But in this case, for multicasting framework, there is no direct interaction. Usually, most children have no direct network connection, a TCP connection, a TCP protocol connection. So we should not use request queue. We should not respond the generated responses to any other to its parents directly. We need to send this response to the random point rather than reply through a direct connected network connection. So here, so for that, we just need to extend notification queue. So we just send the generate responses to the root. So another internet connection is constructed. So we should not use request queue in this case. You must pay much attention to this issue here. Okay. Extend notification queue and the request. The request is should be search query request, right? Yes, that's it. Okay, extend. And then, okay. So this one is a request. That's later, but we need to follow the notification queue design pattern rather than request queue design pattern, although they are similar to each other. For notification queue design pattern, there are no respond method can be invoked. Okay, the response. Pay much attention to the response. Okay, this is the response we need to send to the renderer point, the root in this case. Request. You can see here, this is get notification rather than get a request. Okay. Before we need to process this request, we need to forward, because this is a broadcast. This request is a broadcast, so we need to forward this message. Search child multicaster. Forward this message to its children. It should be read, right? We just follow this example. This read thinks this request should get using this request to generate response, and then send the response to the server, to the root. Sorry. We need to display something on the screen. Request. Get a query. Query will be displayed on the screen. And then we need to retrieve the data. We use the DB we just created. Okay, we use a key to use a hash key to retrieve whether data exists or not. So we need to use this one to generate the key based on the query. Okay, it is received. It will exist. I'm sorry. It is received. Exist. We can generate, right? Generate this value. Generate this response. Let me take a look at this. If it exists, the response can be generated. Okay. Okay. Okay, we need generate the value. And then we need to keep this very important. Keep the collaborate key okay, keep the collaborate key because this collaborate key is very important for each session of multicasting. There is a collaborate key, unique collaborate key. So the random point can differentiate the responses based on such key. Okay. Then if no such method, no such value, we just define, maybe we can define a new, empty or something. Design one particular message that represent the value no such result can be searched. Okay. So here we need to search config no any result to match this query. Then we use search child peer to notify the root responses is generated. Okay. Then we need dispose this message. Okay. After all the message is sent, we can dispose it. Then, okay, wait. This is hold on. We have done this many times. Okay. Okay. So the search is finished. Maybe we can delete something. Display something. Okay. Put here. Okay, so for this case, we just need to, oh, not this one, create the creator. Okay, creator. The creator is the one for notification queue, not for request queue. You should pay much attention to that. A row is called request thread. Okay. Oh, the thread. What the name of thread? Okay. I use the wrong name. Okay. Okay. What else? Then we can copy this code. This one is still notification dispatcher, right? Okay. This requires search broadcast. Okay. Then you move this to line. Next, we need to program the initialization code. Let me check whether we have some. Oh yeah, we have still this one. This one should need to be implemented. This is for shutdown. I hope this because we have a lot of children. We will start to run. So I hope I can stop this code. Let's stop this all the children. So I need to implement this code for the application. Okay. We reuse this message, so we do now need to re-implement such a message. Okay, copy these lines. Okay, this one is different. We need to change this one. Search should be search child multicast. This one should be able to reuse, but I program it again. It's not good enough. It's fine. I think this line is not useful. Okay. So the after this one, after message, this notification receive, it should be the notification. This is broadcast notification should be forwarded to all of its children. These children have his own children, so this message is forwarded. But this one should use synchronous notification, synchronous rather than asynchronous. And after that, just stop this local pair. Okay. Okay. Create this code. Okay. Everything is looks fine. Okay. Everything looks fine. Copy this code. Okay, this project here, this is third time. It's third time for us to program this application. I hope I can create all of our application online step by step. So I hope that will help you to understand this framework, these techniques, this programming methodology. This help you to understand programming techniques easily, right? This way is a good way to learn a new programming languages or new programming environment. Okay. Next. Okay, for this case, copy it here. Okay, replace those placeholders. All of the code follow the exact same design patterns of server dispatcher, notification dispatcher. Okay, let us close. Okay. Close so dispatcher. Okay. Process. Okay, the same thing. Okay, we need to make some changes here. Okay, we do now need to use these things. Okay, next. The crawl data notification should be processed. And then copy this notification. Okay, next, the query should be processed as well here. Copy this lines. Okay. What else? This one, the last one, we can copy this last one. Shut down, the code is exactly the same. Copy this one. Okay. So dispatcher finished. Now the cluster is almost constructed. Let me check the code. Okay, this is the root we programmed. This is the child. Okay, we need to finish this one. Open the code. Example. This is the code. Start. All the starting point are the same. Copy them here. Remove. Okay. Okay, finished. So after right now we almost finished the not cluster. The multicasting framework is still not cluster. We'll introduce you the cluster code next time. But as this time, I still call it multicasting framework rather than a cluster. So cluster has some other additional requirements. So for this case, I call it multicast framework, but it's very similar to a cluster. Okay, so next, what we need to do. I think the children side is finished. The multicasting framework is almost done. And then we need to construct the client. The client will send data. As one client is a crawler, another client is a crawler. So this is a client. So we first design the crawler. Okay. And then for the client, we also, it's better for us to, client is easy. So I don't want to spend much time on the client side. So we just follow an example here. Okay, this is a example we can follow. Okay. This is a crawler. Just call it a crawler. It's a very simple one. It's not a real one, right? Because we have no so much time. But the distributed framework is good, the quality, because we use the API program, but the upper level application is simple. So this code, actually, I think we can reuse this code. Okay, if we want to reuse, we do not need to program it. Okay. Okay, just want to reuse it. No, it's another in another project. So, okay, we just program it. You can see a lot of code is same. So this code actually can be reused. In the next step, I will show some simplified application, the simplified implementation. But this time, yeah, we need to copy a lot of code. But although they're same, it's not good. We can reuse this code actually. Okay. And the crawler need to send the data to the server. So it is not so this method is not necessary. Just send the data to the server. We can it's just use this one is enough. And the IP address, we need to get the IP address of the root. The IP address of the root. So it get from, let me say the name of the root. Why the name is the same as this one? If the root, when the root is started, if the name is different from this one, it's impossible for us to get the IP address of the root. Let me check. Okay, that's the same. Okay, it's fine. So, okay, let us return here. This is a crawler. Let us the crawler, you need to retrieve data. How to generate the data? Here, let me I create I use this code. Let me check this one. This is testing. I use this one. You can see here all the data is because the crawler is not a real one. We just do implement a simulation of the crawler. So we put all the data into a text file. So we run this code. If we run this code, and then all the data will be generated. From the text. When the data will be loaded into the memory, so we can send into this list. So each element of the list will be sent to the multicasting framework one by one. So in this way we can simulate what's the crawler, right? So here we design the make method to start a crawler. Okay, load the code. It's better for us to define the parse here. There is the config, right? We need to put the parse. Put the text file. Test data on the one directory. For example, here, put it here. Okay. Maybe you can use this text using this file. Okay, continue use the file. Okay, next, when the system started, just load. Just load. Search config. Load all the data into the memory. We can keep the data within the memory in a list. It's a string list, and then we define a we design a loop to send such data. Message. The message is that's very important. Let me check the message. It's a message. The client notification doesn't matter. Notification is fine. You can still use the same thing we just mentioned in the previous classes. The notification is different, so we just use new this same notification. Okay, use this one. Send such data to the framework, and then we can sleep for some time. Okay, we declare another constant here. Maybe 2 seconds. And then the data will be sent to the server. Okay, so we print something. Okay, print something here. Okay, I think it's done. For the quarter it's easy. Part is easy. Just use the same notification. Okay, next we need to construct another package. Sorry. Searcher. It's another client. This client will send data to the query. Send query. searcher. Searcher. Okay, for this clan, I also need to copy some code. Okay. Copy this code. And what else? Then we need to send a query. Send query, we need to use this method. Okay, so it's done. Next, we need to invoke, type something. Using type something and send the query. So we type some keyword and send a query to the framework. Okay, next. In this case, we need to use this scanner to get input, the query, the keyword, then the query should be tapped in this way. Then what else? We can check. Okay, the query. Design a simple client. Okay, here. If the equal Q, the system will finish, right? So this is just a simple menu. A simple client. If it's not equal Q, we continue. So searcher. Here you must pay much attention how to access, how to get the response. Okay, let me check. We need to check here. Okay, you can see the response is obtained in this way. The response here is, in our case, the response is client search query response, right? This is the response. So the response searcher read, send the query. To the server. Okay, cast is required. Cast. Through this exception, and then we can display. Display the message, the response. The results. You can see the results is a list, right? No, sorry. It's a list. In the list, all the responses are put into a list that is collected by the root, so we can display the results. Maybe we can do that index here. Okay, results. Okay, it's almost finished. I think maybe there's some problem when I try to run such a system because I just program online. It's normal. I think even though this system is simple, people always make mistake when programming. So in the next class, I will just show this demo only, so you can see maybe if we got some problems in the next class, I will fix this online immediately. And okay, I think even though some problem exist, it should not be so difficult to be resolved. Just maybe type error or some we just make a copy paste, maybe some IP address, some problem, just not so difficult. So because we just program such a difficult system, this is a complex system, no problem, right? It's a complex system. So however, when we program such a system, it's easy because our system, when we program using grid free, it's a really highly patterned programming environment. So it's impossible for us to make big mistake. It's very easy to fix this online. So I just finish here. Next time, in the next lecture, I will run such a system, and if any problem exists, I will fix it online. I will, through these exercises, you must understand it's really easy to program with grid-free. Grid-free is flexible and generic. Okay, that's all for today. Thank you so much. See you next time.